Okay, welcome back, young students of chemistry. In the last recording, you learned how to write formulas for compounds when you're given a name. Today, you're going to learn how to look at a formula and write the name of the compound. So really, it boils down to two things. We have to identify or classify the compound as either ionic or covalent. And if it is ionic, we're going to name the ions. Name the ions. If the compound is covalent, it's all about prefixes. So covalent compounds are about prefixes. Ionic compounds are about the ion names. Let's look at the covalent compounds first. Remember that the second element will always end in "ide." The second element also always gets a prefix. The first element never gets a prefix if that prefix is the prefix for one, mono. So you can see down here on the examples, N3F2, this compound is covalent. We know that because it starts with nitrogen, and nitrogen is a nonmetal. It is binary. There's only two elements, nitrogen and fluorine. So if we want to label it, it's binary and covalently bonded. We're going to put prefixes on the names of the elements to name the compound. The prefix for 3 is tri. We do not change the name of the first element, so this is trinitrogen. The second element, we change the name so that we drop the last syllable and add the suffix "ide." So this is trinitrogen difluoride. On the first example here, we have chlorine and oxygen. Chlorine is a nonmetal, so we know it's covalent. There's only two elements, chlorine and oxygen, so we know that it's binary. The prefix for 1, indicating 1 chlorine, is mono, so we don't write it. The prefix for 7 is hepta. And that prefix hepta goes on oxygen. Oxygen becomes oxide. Okay, let's go back to naming ionic compounds. And what does that mean, name the ions? It's not that difficult. If it is a cation, and it's a monoatomic cation, the only polyatomic cation that I want you to know right now is the ammonium ion, NH4. But if it's a monoatomic cation, we're talking about things that come from our periodic table, right? We're not going to change the name. Magnesium atom with all of its electrons is called magnesium. Magnesium ion, which has lost 2 electrons, is still called magnesium. However, with the anions on the periodic table, monoatomic anions, we drop the last syllable and add the suffix "ide." Chlorine, the atom with all of its electrons, is called chlorine. Cl-, the atom that has gained an extra electron to fill its octet, is called chloride. Fluorine, the atom, becomes fluoride, the ion. Sulfur, the atom, becomes sulfide, the ion. Iodine, the atom, turns into iodide. Oxygen becomes oxide. I hope you're getting that. Okay, so the only real trick here are these crazy transition metals, the D-block metals. D-block metals are multivalent. They can have a varying number of valence electrons, and because of that, they can form more than one charge. So what we have to do is name the compound with the charge of the ion listed in it. We can see here, and this is a very easy example, they do get harder than this, but if you have 10 SnCl2 as the formula, we're going to calculate the charge of the 10 by looking at the charge of the chloride ion. So we calculate the charge of the anion the cation, by looking at the charge of the anion, chloride. And we know that the charge of chloride is -1. We don't know what the charge of 10 is. I'm going to call that X. There's 1 10, so I'm going to say 1X plus chlorine, which is -1 times 2 because there's 2 chlorines. So 1X plus -2 has got to add to equal 0. All compounds are electrically neutral. So here we can see that X is equal to 2 plus. And that's where we get this Roman numeral 2. So if we have chromium here and we want to know the charge of it, here we have a subscript of 2. So we're going to say 2x plus the oxygen's charge is -2. -2 times 3 is -6. 2x plus -6 must equal 0. Therefore, x must equal +3. So we would call this the chromium 3 ion. Okay, I think it's best if we just get into naming some compounds. Remember that if it's ionic, you name the ions. If it's covalent, we're going to add prefixes. That's it. So if we look at the first compound, we can see that this compound is ternary. We know that because there's calcium, phosphorus, and oxygen. There's more than 2 elements. This compound contains a polyatomic ion. All ternary compounds are ionic, and for ionic compounds, we just name the ions. Ca is the symbol for the word calcium. PO4 is the symbol for the word phosphate. It follows our rule that all ternary compounds will end in ate or ite, and phosphate is on your list of polyatomic ions. You're just going to have to commit those to memory. Here we have a binary compound, just calcium and oxygen. Calcium is a metal, so it's ionic. We know that when we're writing the name for an ionic compound, we simply write the names of the ions. Ca is the symbol for calcium. O is the symbol for oxygen, and as an ion, we drop the last syllable or 2, and we add the suffix "ide." So this compound is calcium oxide. This compound is ternary, so it contains a polyatomic ion, lithium, carbon, oxygen, more than 2 elements. We're going to name the ions. It's only going to have 2 ions, a cation and an anion. This is our cation. This is our anion. Cat, an, cat, an. So the name of our cation, Li, is lithium. The name of our anion, CO3, is carbonate. That's on your polyatomic ion list. P2O4 is binary, and it is covalently bonded. If it's covalent, prefixes, prefixes, prefixes. So the prefix for 2 is di. Don't change the name of the first element, so this is diphosphorus. The prefix for 4 is tetra. Oxygen becomes oxide. We do change that name. And that follows our rule that all binary compounds end in the suffix "ide." KBr, this is binary and it's ionic. No prefixes for ionic compounds, just name the ions. K stands for potassium. Br is bromine, and the Br minus ion is what we call bromide. And again, binary compounds end in "ide." We learned that when we were writing formulas from names. Couple more, and then I'm going to let you go with it. Here we have a ternary compound, and here's the tricky thing. We have a transition metal. This is a D-block metal, so we're going to have to calculate the charge of that metal. Let's do that first. So we know that we don't know the charge, so we're going to call it X. There's 3 of the iron ions. And then we know that phosphate, because we know our polyatomic ions, has a charge of -3. And there are 2 phosphate ions. So -3 times 2 is -6. Charges always have to add together to equal 0 because electrons lost must equal electrons gained, and compounds are electrically neutral. So if we solve for X, X is going to be 2 positive. So this Fe stands for iron. So we're going to put a Roman numeral 2. Iron 2, and then our second ion, right? This is our cation, this is our anion, is going to be phosphate. Here's another one. This is a binary ionic compound that contains a transition metal. If we calculate the charge of the nickel, we find that it is 2 positive. So this compound is nickel, Roman numeral 2, chloride. We know the charge of nickel is X. The charge of chlorine is -1, and there's 2 chlorines, right? So X is equal to 2. Strontium is a metal, so this compound is ionic. There's only 2 elements, so it's binary. If it's ionic, we just name the ions. And strontium is not a transition metal, so we do not need a Roman numeral. So this is just strontium. Carbon becomes carbide. Drop the last syllable and add the suffix IDE. The last one I'm going to do with you here is binary. There's only 2 elements, and it is ionic because Al is on the left-hand side of the periodic table, making it a metal. So if it's ionic, we just name the ions. The name for Al is aluminum. Aluminium if you are British. P is phosphorus. We drop the last syllable and we add the suffix "ide," phosphide. Do not forget what you learned when it came to writing formulas. You learned that if you look at a name and it ends in "ide," IDE, then it is binary. If you look at a name and it ends in ATE or ITE, then it is ternary. So when you write your names, you should follow that rule. That's not going to change because we're working this in reverse. Okay, I hope that has helped out, and I look forward to seeing you and actually talking chemistry with you. We can stop spelling to each other, and we can start communicating for a change.